Hi everybody. I noticed a bunch of us may have been absent when we went over area models, and I couldn't find a video that I quite liked, so I'm going to make one for myself. So area models, we're talking about multiplication, okay? Let's start with this problem reads 3 5/10 multiplied by 7 1/10. Right, so we set up area model. I like to draw a box. If I have more digits with value, my box would be bigger, but I only have 4 digits with value, so I just need a small box. Okay. So I like to put my first factor on top and my second factor on the side, but it doesn't really matter. It's all up to you, as long as you keep each piece of the factor with its other part. Now, I've written the values, but is this 5 really a 5? This 5 is not just a 5, it's actually 5/10. So I need to make sure I know what place value I'm working with when I use the area model. Same thing with my 1. My 1 is not really a 1. It is 1/10. We have to remember place value as we go. So you can start on any box. It doesn't really matter. You're going to fill in all of them based on the factors that you're using. All right, so the first one that I like to do, I like to go how we read. So top to bottom, left to right. That's just how I roll. So 7 multiplied by 3 is 21. 7 multiplied by 5 is 35. 3 multiplied by 1 is 3. And 1 multiplied by 5 is 5. But I didn't just multiply 7 and 5, or 3 and 1, or 1 and 5, did I? No, I multiplied 3 and 1/10, 7 and 5/10, and 5/10 and 1/10. This one I really did multiply 7 and 3. Don't worry about that one. If you're multiplying whole numbers, you're good to go. But in these ones, we need to look again because our answers should have some decimals somewhere. The question is where? Where should they be? Right? So let's look at our problem. We know that we have zeros all over the place, right? We could write zeros in on either side of these till we're blue in the face. But these zeros, they don't have value, okay? An example would be, this number reads 2/10. Okay? This 0 does not have value. This 0, we could technically give it value and say 20/100ths, but we would simplify it and still not give it any value. Okay? This 0, however, does have value. Why do you think that is? This 0 has value because it changes where the 2 sits. These zeros didn't change that. This one does. Same thing with whole numbers. If this is our 1's place, if we add a 0 here, does that change that I still have 3 1's? It does not. But if I put a 0 here, this is not just 3, it's 30. Okay, this 0 would have value. This 0 has value. These do not. Okay. All of this to say, while we are looking for places to put our decimals, we need to pay attention to where or how many place values have value in our problem. So this whole numbers, we're good. Okay, we know how to do that. But here we multiplied 7 and 5/10. Okay. Now, if you look at this, I have one place that has value behind the decimal and one place that has value in front of the decimal. Okay? We need to make sure our answer has at least one place with value behind the decimal. And we can check this. We can check this because this problem means I have 7 groups of 5/10. 7 groups of 5/10. So if I count 7 groups of 5/10 out, watch this. 5/10, 1 whole, 1 1/2, 2, 2 1/2, 3, 3 1/2. When I counted out 7 groups of 5/10 or 1/2, I got 3 wholes and 1 more half or 1 more group of 5/10. Whenever we counted, did we get the same thing as when we multiplied and moved our decimal? We did. Let's try on another one. Over here, we had 3 multiplied by 1/10, right? Okay, this means I have 3 groups of 1/10. Okay, now if I count it, I would have 1/10, 2/10, 3/10. Okay. So according to that idea, our decimal needs to go here. Let's check if our other idea would work too. I notice I have one place value that has value behind my decimal. And in my answer, I have one place that has value behind my decimal. So that means my decimal needs to go there. This is where it gets a little trickier. If we use what we know here, we can do this. We've realized that we need to have the same number of places with value behind our decimal in our factors and our product. Okay. So let's think about this problem. We have 1/10 multiplied by 5/10. Okay. So let's think about it. We have one place behind our decimal here and one place behind our decimal here, which means we have 2 total places behind our decimal that have value. Okay, that means in our answer, we need to have 2 total places behind our decimal that has value. Okay, I got the answer of 5 when I just multiplied my numbers. Okay, if I added my decimal here and put a 0 here, would that 0 have any value? It would not. What if I added a 0 here? Would that 0 have value? It would. It would change it from 5/10 to 5/100. And it would give us the 2 spaces of value that we need inside our decimal. Now, if we move on to our next step, we'll see that we need to add. All right, we're going to add right up here. I'm going to take the things that I see in my box. I'm going to add them together. Okay, here we go. 21, 3 1/2, 3/10, and 5/100. Gonna run out of room, sorry y'all. Okay, so I'm adding. You can also always feel free to fill in the spaces as you need. If that helps you make sense of it, you put them in there. I get distracted by them. Okay, so I have 8 here. And when we add, we bring our decimal straight down, as long as it's all lined up. Okay, so my answer is 24 and 85/100. I'm going to rewrite that over here for us. 24 and 85 hundredths. Okay, now let's check and make sure that we're right. We're going to use my calculator on my phone. So don't make fun of me as I show you my phone. All right, here we go. Now, we know calculators can be wrong if we type things in incorrectly. All right, so we need to make sure that I type it in correctly. So check Miss Rhodes as she goes. We have 3½ multiplied by 7 1/10. I got 24 and 85 hundredths. So we got it right.